students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we will be learning a very interesting topic, that is multiples and factors. Now in this chapter we will learn about multiples and its properties, factors, divisibility rules, prime and composite numbers, even odd numbers, HCF, LCM, prime factorization and some problems on HCF. Now let's look at, we have to choose a correct answer. What is a factor? The number multiplied by another number to find a product. That's how you can complete the remaining part. Now let's start with multiples. Let us revise the multiplication table of 5. Now 5 times 1 is 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 multiplied by 5 is 25, 5 6s are 30, 5 7s are 35, 5 8s are 40, 5 9s are 45 and 5 10s are 50. Now the numbers 5, 10, 15, 20 all are called the multiples of 5, and here are the multiples of 8, 16, 8. Here are the multiples of 10, that is 10, 20, 30 and so on. Here are the multiples of 15, that is 15, 30, 45, 60 and so on. So we multiply a number by 1, 2, 3, 4 and so on, and we get the multiple of that number. Now let's look at the properties of multiples. Now every number is a multiple of 1 and a multiple of itself. Now the smallest multiple of a number is the number itself. Now every multiple of a number is equal to or greater than that number, and the multiple of a number are endless, so there is no greater multiple of a number. Now the multiples of 2 are called even numbers, and the multiples which are not a multiple of 2, that numbers are called odd numbers. Now always remember, the multiple of even number are always even, and the multiple of odd numbers are either it can be odd or it can be even. Now how to find multiples? To find the multiple of a number, we will multiply it by 1, 2, 3, 4 and so on. Now for example, we have to find the first multiple of 5 and first 6 even multiples of 4. So these are our 5 multiples, that is 5, 10, 15, 20 and 25, and first 6 even multiples of 4 are 4, 8, 16, 24, 32, 40, 48. Now in the next one we have to find the first 4 odd multiples of 7. So that is, first 4 odd multiples are 7, 21, 35 and 49. Now what is a factor? Let's look at the factors. Now here 6 8s are 48, so the 48 is a multiple of 6 and 8, and 6 and 8 are the factors of 48. Similarly 2, 5 and 7 are the factors of 70, and they are the multiple of 70. Now similarly 8 and 9 are the factors of 72, because 8 9s are 72, and 2 into 3 into 5 is 30. So 2, 3 and 5 are the factors. So whenever we multiply any 2 or more numbers, we always get a product, and the product or multiple of each number is multiplied, and each number is a factor of that product. Now let's look at the properties of factors. Now 1 is the factor of whole numbers, 1 is the smallest factor. A number is always a factor of itself, and the number itself is the greatest factor of itself. Now a factor of a number is smaller or always equal to that number. Every number has at least 2 factors, that is 1 and the number itself. Now the number 1 is an exception. Now let's look at example number 4. We have asked that whether 5 is the factor of 75 or not. Now after dividing it, we get remainder 0. Here after dividing, here we have to find the factors of 12. So the factors of 12 are 1, 2, 3, 4, 6 and 12. Now let's look at the mental maths. We have to fill in the blanks. Dash is a factor of whole numbers 1. That's how you can complete the remaining part. Now let's look at the divisibility rules. Divisibility rules help us to find out whether a number is completely divisible by another number or not. For example, when we divide it, remainder is 0. When we divide it, the remainder is not 0, that means it is not divisible by 6. Now how to test divisibility? Now here are our divisibility conditions, here are their examples. So for 2, any number divisible by 2, its last digit is either even or 0. So all the digits are even, so that's why they are divisible by 2. For 3, the sum of its digit is divisible by 3. So the sum is 12, so it is divisible by 3. Next is 4. For dividing any number by 4, last 2 digits is a multiple of 4. Last 2 digits multiple of 4. Now for dividing it by 5, last 2 digits are either 5 or 0. Now for dividing it by 6, it should be divisible by 2 as well as 3. So this number is divisible by 2, and when we add them, it is also divisible by 3. Now for 7, a number is divisible by 7 if difference between twice the last digit and the number formed by the digits is either 0 or a multiple of 7. That means when we last digit is 9, 88 minus 18, that is 70. So the number is divisible by 7. Now 8, a number is divisible by 8 if a number formed by then its last 3 digits is divisible by 8. So here this is our number and last 3 digits are 232. So this is divisible by 8. For divisibility by 9, the sum of digits is divisible by 9. So the sum of digits is 9 plus 9, 18 divided by 9. Yes, so this is our divisible. For 10, a number is divisible by 10 if the last digit at unit place is 0. Unit place 0, that means they are divisible by 10. Divisibility by 11, if difference between the sum of its alternate digit is 0 or a multiple of 11. Here 0, so that means it is divisible by 11. Now exercise 4.1, in the first part we have to choose the first 4 multiples of the following and fill in the OMR sheet. First 4 multiples of 3, that is 1, first one is our correct answer. That's how you can solve the remaining part. Now again in this one we have to find all the multiples of 27, so that will be 1, 3, 9, 27. That's how you can complete the remaining part. Now in this one we have to put a tick if the number is divisible or if the number is divisible by 2. Yes, that's how you can complete the remaining part. Now in the next one we have to write the missing factors. So 7 9s are 63. Now next is our prime and composite numbers. Now a man has written all the factors of numbers from 1 to 15 in the table on the left. Now help him circle the boxes to show the factors in the number grid from left to right. Now here are the number factors and here are the numbers. So 3 factors 1 and 3, 4 factors are 1, 2 and 4. Similarly you have to complete it till 15. Now numbers which have only 2 factors, that is 1 and the number itself, they are called prime numbers, and numbers having 3 or more factors are called composite numbers. Now we observe that 1 has only 1 factor, that is 1, 2 has 2 factor, that is 1 and 2, and 6 has 4 factor, that means 1, 2, 3 and 6. Now let's look at the mental math. Write the numbers that have only 2 factors, that is 2, 3, 5, 7. That's how you can complete the remaining part. Now in remember, always remember the number 1 is unique. It has only 1 factor, that is 1. So 1 is neither prime nor composite. Now let's look at the prime numbers between 1 and 100. So about 230 BC, a great mathematician Eratosthenes developed a method of finding prime numbers, that how we can find prime numbers, and this method is known as the sieve of Eratosthenes. Now firstly look at this number grid. Firstly we will cross out the 1, then we will leave 2 as prime and we will close all the even numbers, then we will leave 3 as prime and cross out all the multiples of 3, then cross all the multiples of 5, all the multiples of 7, and then circle the multiples or the numbers that are left. So the numbers that are left are our prime numbers. So in the first row they are 2, 3, 5, 7. Now let's look at the even and odd numbers. Every even composite number can be expressed as a sum of 2 prime numbers. A number which is multiple of 2 is called an even number. A number which is not a multiple of 2 is called an odd number. Now in other words, odd number are not exactly divisible by 2. Here are the even composite, here are the sum of 2 prime numbers. Now here 2 is the only even prime number. Now here we have to express even composite number as sum of 2 prime numbers. So 10 can be expressed as sum of 2 primes, that is 5 plus 5. That's how you can complete the remaining part. Now next is our prime factorization. All composite numbers can be expressed as a product of their prime factors. Now here is the prime factorization. 2 6s are 12, then 2 3s are 6. Similarly for 20 and 27. So the composite numbers are 12, 20, 27 and there are their prime factors. Now a factorization having each factor as a prime is called the prime factorization of the number. Now here is our prime factorization method. Let's learn that. Now let's understand it better with the help of example of prime factorization of number 56. So in step 1 we will divide 56 by the smallest prime number 2, then again we will keep on dividing it by 2, again 2. Now after that we get 7. Since 7 is a prime number, no further factorization is required and this is our prime factorization. Now next is by factorization by factor tree method. Now here is a prime factorization of 48 using the factor tree method. Now we know the step that smallest prime number factor is 2. So we will pair it with 24 and 2. Then next smallest prime number is again 2 and 12, then again 2 and 6, and we know that 6 is the smallest one and its prime number is 2 and 3. So the prime factorization of 48 is 2 into 2 into 2 into 2 into 3. Now let's look at the mental math. We have to find the prime factorization of this using the prime factorization method for 42. So here is our 42. By 2 that is 21, then by 3 that is 7, then 7, then 1. That is the prime factorization of 42. That's how we can solve the remaining part. Now let's look at the highest common factor or HCF of 2 or more numbers is the greatest number, that is the factor of given number. Now let's look at the properties of HCF. HCF of 2 or more numbers is greatest common factor. HCF of given number cannot be greater than the number themselves. Now if number is a factor of another number, then the smaller number is the HCF of two numbers. For example, in case of 3 and 15, 3 is a factor, so that means the HCF of 3 and 15 is 3. Now the HCF of two numbers is 1, that means they are called co-prime numbers. For example, HCF of 13 and 19 is 1, so they are co-prime. Now consecutive numbers are always co-prime. For example, 4 and 5 co-prime, then 9 and 10 are also co-prime. Now how to obtain the highest common factor? Let's understand it better with the help of example. We have to find the HCF of 12 and 18. Now here are our factors of 12 and 18, then the common factors are 1, 2, 3, 6. Now the highest common factor is 6, so HCF is 6. Now we have to check whether 12 and 6 are divisible by 6. Yes, both are exactly completely divisible by 6. Now let's look at finding the HCF factor method. We have to find HCF of 8 and 20. So here is the factors of 8, factors of 20, common factors are 1 to 4, highest one is 4, so this is the HCF. Now prime factorization method, example number 10, we have to find the HCF of these numbers using the prime factorization method. Factors of 18, 27 and 33, common factor is 3. Now in example number 11, we have to find the HCF of 24, 36 and 48. So here is the factorization, prime factorization. Now the common factors are 2, 2 and 3. Now the highest common factors are 2 into 2 into 3, that is 12. Now let's look at long division method. In example number 12, we have to find HCF of 375 and 825. Now for the smaller number is 375, so we will divide it by 875. Now 375 becomes the smaller number and 75 becomes the dividend. After dividing it, we get our remainder 0. That means HCF is 75. Now in example number 13, we have to find HCF by the long division method. Again 35 divided by 49, 14 and 35 becomes the dividend. Again after dividing it, 7 divided by 14, so the remainder is 0. That means the HCF of these numbers is 7. Now let's start with exercise 4.2. In all of these parts, we have to find the HCF of all these factors. Now let's start with the first one, 15 and 30. For finding the factors of 15, common factors are 1, 3, 5, 15 and 30 common factors are 1, 2, 3, 5, 6, 15, 30. So the highest common factor is 5 and 50. That's how you can complete the remaining part. Again in the next one, we have to find the prime factorization. Now let's look at the LCM. Now the lowest common multiple or LCM of 2 or more numbers is the smallest multiple among all their multiples that can be divided by those numbers without leaving a remainder. Now let's look at the properties of LCM. Here are the properties of LCM. That LCM of 2 or more numbers is the smallest common multiple, and LCM of two or more numbers is the smallest number that is completely divisible by each of the numbers. So the LCM of 8 and 16 is 24, is divisible by 8 and 6. Now the LCM of two or more numbers cannot be less than the number themselves. Now the number is a factor. If one number is a factor of other, then greater number is the LCM. For example, in case of 3 and 15, 3 is a factor of 15, so LCM is 15. Now let's understanding LCM. Now let us see the multiples of 2 and 3 on the number line. Here are the multiples of 2 and 3 on the number line. Now here are the multiples of 2, multiples of 3. Common multiples are 6, 12 and so on. Now we know that the smallest common multiple is LCM, so 6 is our LCM. Now finding the LCM prime factorization method, let's look at example number 12. We have to find the LCM of 28 and 30. Factors of 28, factors of 30. Then we will circle the common factors, that is 2, 2, 3, 5, 7. So by multiplying it, 420 is our LCM. Now in example number 13, we have to find the LCM of 10, 15, 18. Prime factors of 10, 15 and 18. Here are the common factors, so the LCM of them is 90. Now let's look at the short division method. This is a quicker way to find LCM. Now let's look at example number 14. We have to find the LCM of 8 and 12. Now in step 1, we will divide the common factor and write the quotient below these numbers. Then if a number cannot divide, we will copy the number exactly. After that, by continuing divided the common factor, stop when there is no common factor. Now the LCM of these numbers are 2 into 2 into 2 into 3, that is 24. Similarly, in example number 15, we have to find the LCM of 12, 16 and 24. After multiplying these numbers, we get our LCM as 48. Let's start with exercise 4.3. In the first one, we have to find the LCM using the prime factorization method, and in the second one, we have to find the LCM by the short division method. Now let's start finding the LCM with the short division method. Here is our 35, here is our 70. Firstly, we divide it by 2. This becomes 35. This becomes again, that is 2 3s are 6 and 2 5s are 10. Now by 7, 5, 5, then by 5, 1, 1. So 7 5s are 35 and 2 70. So 70 is our LCM. That's how you can complete the remaining part. Now let's look at the problems on HCF and LCM. In example number 16, we have to find the lowest number which is exactly divisible by 15 and 26. Now we can find the LCM of 15 and 30 to get the required number. So we have 15 and we have 20. So now here 15 and 20, so when multiplied it by the prime numbers, we get 60 as their lowest common factor. Now let's look at example number 17. We have two wires of length 18 and 24 meter each. The wire to be cut into small pieces of same length. What can be the maximum length of each piece? For this, we will find the HCF of this number. So here are the factors of 18, factors of 24, common factors, and highest common factor is 6. That means maximum length of each piece will be 6 meter. Now let's look at example number 18. We have to find the lowest number when divided by this leaves the remainder 3 in each case. So after finding the LCM of these numbers, we will add 3, and 27 is the lowest number when divided by all these numbers, leaving remainder 3 in each case. Now let's look at exercise 4.4. In the first part, we have to find the highest number which divides 27 and 45 exactly. For finding the highest number, we will find the HCF of 27 and 45. That's how you can complete the remaining part. Now let's look at the think tank. In the first one, we have to take the correct option. 1, 2, 4, 5, 10, 20 are the factors of 20. That's how you can complete the remaining part. In the next one, we have to match column A with the column B. So this is our 2 2s are 4, 2s are 8, 5s are 40 into 9, that is 360 is our correct answer. That's how you can complete the remaining part. Maths puzzle, we have to find the HCF and LCM of these numbers. So for finding the HCF and LCM of 6 and 9, so that is 1, 2, 3, 1, 3, so HCF is 3. That's how you can complete the remaining part. Next is mental math. We have to take the correct option. LCM of 10 and 25 is. So here is our 10, here is our 25, Firstly by 2, 5, 25, 5 again by 5. So that is 5 5 is 25 to 50. So B option is the correct answer. That's how you can complete the remaining part. Next is our activity zone. The numbers given in the cloud should be placed in the circles below. The numbers that are divisible by 2 and 9 should be placed in the overlapping region. So the number divisible by 2 is 108, 96, 180, divisible by 9, 180. So 180 can be overlapped. That's how you have to complete the following region. Now I hope you have understood the chapter pretty well. You just have to practice exercise questions and don't forget to revise this topic again.